All right, so for this one, we're gonna go over what's gonna be on your test, okay? Um, After spring break, right? So these are the topics you're gonna have to go over during spring break, okay? And so the first one, okay, we start off with I think the last sort of section of chapter 8, so 8.8. Um, we evaluated improper integrals, right? So on your test, they're all going to be improper, right? It will actually say that on the directions. Evaluate each improper integral. So the first thing you need to do is obviously determine why it's improper, right? So you have to figure out, okay, what makes the integral improper, and then based off of that, okay, then you do or you evaluate it using the limits, right? So using the limit method, you should be able to evaluate the improper integral if the limit exists, right? So again, just to sort of to reiterate, it's going to be improper, right? So it's going to be improper. You're gonna have to figure out what makes it improper, and then use the limit method to evaluate the improper integral. So make sure you do that on your test. Okay, and then we move on to essentially what chapter 10 was all about. And so the first thing on chapter 10 was sequences. Okay, so given a sequence, make sure you know how to find the nth term of a sequence, right? So finding the formula for your sequence. And then more importantly, make sure you're able to determine if a sequence converge or diverge, right? So for this one, just simply take the limit as n goes to infinity. And if the limit exists, then um, your series or your sequence is gonna converge. Okay, and so let me move my chat over here so I can see it at the same time. Okay. All right, and so that's determining if it could converge or diverge. So remember, do not confuse sequences with series, right? So um, sequences, all you're doing is taking the limit as n goes to infinity and just making sure that the limit exists. Okay, so if the limit exists, then your sequence converge or diverge. It's a little bit different on a series, right? So in a series, when you take the limit as n goes to infinity, that is only for your nth term or your divergence test. Okay, so do not confuse the two when you get on your test. So now moving on to the next one, which we actually sort of just already mentioned, it's series, right? So on a series, using one of the tests, determine if an infinite series is going to converge or diverge. And so I think if I remember correctly, there are 10 different tests. So there's 10 of them. And let's see if I can actually bring it up. Open put it over here for Cal Poly 1150. Oops, that's 1150. 116 series sheet. Okay. So again, this series, right? So this is on Pearson, right? So there's actually 10 of them. So there's 10 tests. So make sure you can use or determine if a series converge or diverge based off of this. Okay. So that's the first part. Make sure you know how to find the sum. Find the sum if possible. And if you again look at the series sheet, only two of them has the sum: telescoping and geometric. Right, so those have sums on them. Um, so make sure you know how to find the sum, and then make sure you know how to use the direct comparison test. Right. So as I already mentioned before, I will force you to use the direct comparison test by either telling you can only use a test once, so which means when it's a comparison test, you can only use your limit one time, or I'm going to force you to say, oh, use direct comparison on one of your tests, on one of your series, I should say, right? So make sure you know how to determine how to use your direct comparison test. And then last, absolute convergence and conditional convergence. I think this was the last thing we went over in class, right? So it's an actual in-class lecture. I think this was the last thing that we did before we got into that sort of mini break. And so make sure you know how to test for absolute and conditional convergence, right? So the conditional usually is as an alternating series. The alternating series converges, but once you put the absolute value around it, then the series diverge, which means it's only conditionally convergent. Okay, so make sure you know how to test for absolute and conditional convergence. Again, as I already mentioned before as well, this would be separate from this one, right? So this would be separate from this. Okay, so because I don't want you to confuse the two, right? So they would be two separate problems or separate sections on your test. So that way it's one thing to just know converge or diverge, and then there's another where I just want to know if it's absolute, conditional, or just simply diverges. Okay. And so that's this series is from 10.2 to I think about 10.6, right? So that's about 5 sections on there, right? That we went over for series and just determining if you converge or diverge. Now the remaining sections of chapter 10 are all about your power series. Okay. So the first thing you need to be able to do is find the radius and interval of convergence. So this was, I think, the very first lecture that was done online. Okay, so there are three possibilities. It only converges at the center. It converges everywhere, so from negative infinity to positive infinity, or it converges on a certain interval. Um, so make sure you know how to do all three. Now remember, for the one where it converges on a certain interval, you have to test the endpoints to see if the endpoints are going to be brackets or parentheses as far as your interval are concerned. So you're gonna have to plug them back into your power series and see if the resulting infinite series is gonna converge or diverge, okay? And then sort of the next things are sort of the last few things is finding the power series representation of a function. So one of them is using the geometric series, right? So we did that first, and then using Taylor and Maclaurin, right? And so especially for the Taylor one, so the Taylor one is where the center is not zero, right? So be ready to do a Maclaurin or a power series representation when the center is not zero, and that's where Taylor basically sort of comes in. And then the operations with power series. So for the operations of power series, you're using the list that was we derived for your Maclaurin, and then you use that to either add, subtract, or multiply um, sort of polynomials from there to find the power series representation. And then last is what we did today, right? So error estimation, the number of terms needed to give a maximum error, integrating. There's some that requires derivatives and so on and so forth. So make sure you know how to use power series as an application. Okay. Any questions on that? Okay. And so that's it. That's going to be covered. That's what's going to be covered on your test. Okay. Any questions on this?